Before starting with the application, I want to explain a very important point about the choosing the object. In general, we have to use two kinds of a charged object. The first one, we can say metallic or conducting charged object, or we can say another kind of object. We have just a uniform charged object. You have to distinguish between these two objects because the calculation will be definitely different. Let's take the case here. We have a sphere. This sphere, it's full, okay? It's not empty. It's not a shell. It's a full body, full object. This object has a charge Q. The total charge is Q, positively charged. In the case of the metallic charged object, these positive charges must be distributed on the surface of this volume. So, like this. Okay, I am drawing 3 dimensions, but we cannot see here. Okay, we have just on the surface, but Q inside here equals to 0. We don't have any charge inside. All these charges are distributed on the surface. The volume of the sphere, you know that, equals to 4 over 3 pi r cube. R is the radius of the sphere. And Q, you know, we talked in the last chapters about Q. If you have a linear charge distribution, we take lambda. About the area charge distribution, we use sigma. In the case of the volume charge distribution, we use rho. In our case here, the charges are distributed only on the surface. So the charges must be equal to sigma A. We cannot say rho, we cannot say Q equal rho times V, because it's not, we don't have the case of volume charge distribution. Okay, the distribution is on the surface. In this case, we can write sigma A, the area of the surface where you have the charges, equals to 4 pi, here we have the area, equal r square. It's very important. Now, I want to take the same example and the same object with the same shape, a sphere, But this sphere is not a metallic object. It's just a uniform charged object. Okay? In this case, the charges will be distributed at any point in the object. We can have the total Q positively charged, and we have at any point a positive charge like this. So the total volume of this object equal 4 over 3 pi r cube, but Q, in this case, you have a volume charge distribution, Q equals to rho times V, equal rho 4 over 3 pi r cube. So the volume of the sphere equal the volume of the charges, the volume of the um, of the charges are distributed on all the volume. Okay, and here we can distinguish between these two metallic objects. Two objects, the metallic and the uniform charge object. We can take another example. Maybe you have a cylinder also. Let's say here we have a metallic cylinder. In this case, for this metallic one, the charges must be distributed only on the surface of this object, like this. Okay, we don't have inside. Q in equals to 0. We don't have Q inside. And you know the volume of the object equal the area of this one times the height, equal pi. We can say here we have r, okay, equal pi r square times h. And Q total of the object, Q, here we have a surface charge distribution. We don't have volume because we don't have a volume inside. So we have to write sigma times A. Okay? And you can write the area of this object, which is equal to the perimeter of this disk times the height, equal to pi r times h.